Hello everyone, myself Roopa. In previous session, you might have studied the nature of the sequences, the definition of monotonically increasing and decreasing sequences and bounded sequences. In this session, we will discuss the problems on monotonically increasing and decreasing sequences. Show that the sequence xn where xn equals 3n plus 4 by 2n plus 1 is monotonically decreasing, bounded and tends to the limit 3 by 2. Solution. The given sequence xn equals the sequence 3n plus 4 by 2n plus 1, that is xn equals 3n plus 4 by 2n plus 1. Here replace n by n plus 1, we will get xn plus 1 equals 3 of n plus 1 plus 4 by 2 of n plus 1 plus 1. On simplification, we will get 3n plus 7 by 2n plus 3. For first condition, consider xn plus 1 minus xn. We are applying the value of xn and xn plus 1 here. We will get 6n square plus 7n, 17n plus 7 minus of 6n square plus 17n plus 12 by 2n plus 3 into 2n plus 1. On simplification, we will get minus 5 by 2n plus 3 into 2n plus 1 is less than 0. That implies xn plus 1 minus xn is less than 0 for all n. That implies xn plus 1 is less than xn for all n. Therefore, the sequence xn is monotonically decreasing sequence. Therefore, the sequence xn is monotonic. Given xn equals 3n plus 4 by 2n plus 1. Here put n equals 1, then we get x1 equals 7 by 3. As the sequence xn is monotonically decreasing, it is bounded above by its first term 7 by 3. That is 7 by 3 is more than or equal to xn for all n. Also we have 3n plus 4 by 2n plus 1. Here add and subtract 3 by 2. On simplification, we will get 3 by 2 plus 5 by 2 into 2n plus 1. That is more than 3 by 2 for all n. Therefore, xn is more than 3 by 2 and lesser than or equal to 7 by 3. Hence, the sequence xn is bounded. The third condition, consider limit xn as n tends to infinity. Here xn value is 3n plus 4 by 2n plus 1. Limit of n tends to infinity. Here we will take n as a common, then we will get 3 plus 4 by n by 2 plus 1 by n. On applying the limit as n tends to infinity, here by 4 by n, that is 4 by infinity, 4 by infinity is 0, that is 3 plus 0 in numerator. Similarly in the denominator, 2 plus 1 by infinity is again 0. We will get finally 3 by 2. Therefore, the sequence is convergent and converges to 3 by 2. The next problem, show that the sequence xn where xn is 2n plus 1 by 5n plus 3 is monotonically increasing, bounded and converges to 2 by 5. Solution. Given the sequence xn equals the sequence 2n plus 1 by 5n plus 3, that can be written as xn equals 2n plus 1 by 5n plus 3. Here, replace n by n plus 1, we will get xn plus 1 equals 2 of n plus 1 plus 1 by 5 of n plus 1 plus 3, that should be equals 2n plus 3 by 5n plus 8. Consider xn plus 1 minus xn. Here, substitute the value of xn and xn plus 1. Then, on simplification, we will get 10n square plus 15n plus 6n plus 9 minus 10n square minus 16n minus 5n minus 8 by 5n plus 8 into 5n plus 3. That should be equal to 1 by 5n plus 8 into 5n plus 3, that is more than 0 for all n. That implies xn plus 1 minus xn is more than 0 for all n. That implies xn plus 1 is more than xn for all n. Therefore, the given sequence is monotonically increasing. The second condition, given xn equals 2n plus 1 by 5n plus 3. Put n equals 1, then we get x1 equals 3 by 8. As the sequence xn is monotonically increasing, it is bounded below by its first term 3 by 8. That is, xn is more than or equal to 3 by 8 for all n. Also, we have 2n plus 1 by 5n plus 3. Here, we add and subtract 2 by 5, then we will get 2 by 5 plus 10n plus 5 minus 10n minus 6 by 5 into 5n plus 3 for all n. On simplification, we will get 2 by 5 minus 1 by 5 into 5n plus 3 is less than 2 by 5 for all n. Therefore, xn is more than or equal to 3 by 8 and less than 2 by 5 for all n. Hence, the sequence xn is bounded. The third condition, consider limit xn as n tends to infinity. Here, the xn value is 2n plus 1 by 5n plus 3. On simplification, here we will take n as a common, then we will get limit of n tends to infinity 2 plus 1 by n divided by 5 plus 3 by n. And applying the limit as n tends to infinity, we will get 2 by 5. Therefore, the sequence is convergent and converges to 2 by 5. The next problem, test the convergence of the sequence whose nth term is 1 plus minus 1 power n. Solution, given xn equals 1 plus minus 1 power n. Replace n by 2n. That is x 2n equals 1 plus minus 1 power 2n. Here the value of minus 1 power 2n is 1. Therefore x 2n equals 1 plus 1. Then x 2n value is 2. Now we will apply the limit as n tends to infinity on both sides. We will get limit of x 2n as n tends to infinity equals 2. Consider xn equals 1 plus minus 1 power n. Replace n by 2n plus 1. That is x 2n plus 1 equals 1 plus minus 1 power 2n plus 1. In the right hand side, the minus 1 power 2n plus 1 value is minus 1. Therefore, x 2n plus 1 equals 1 minus 1. That should be equal to 0. When we apply the limit as n tends to infinity, we will get limit of x 2n plus 1 as n tends to infinity value is 0. Therefore, the limit of the sequence is not unique. Hence, the given sequence is oscillatory. Next problem. Test the convergence of the sequence whose nth term is n plus minus 1 power n by n. Solution. Given xn equals n plus minus 1 power n by n. Replace n by 2n. That implies x 2n equals 2n plus minus 1 power 2n by 2n. Here minus 1 power 2n value is 1. Therefore x 2n value equals 2n plus 1 by 2n. Here we are splitting the terms 2n by 2n plus 1 by 2n. We will get x 2n value is 1 plus 1 by 2n. Here we are taking the limit as n tends to infinity on both sides. Then when applying the limit, we will get 1 plus 1 by 2 into infinity, that is 1 by infinity. 1 by infinity value is 0. Therefore 1 plus 0 equal to 1. Therefore, limit of x to n as n tends to infinity equals 1. Again consider xn equals n plus minus 1 power n by n. Here replace n by 2n plus 1. That is x 2n plus 1 equals 2n plus 1 plus minus 1 power 2n plus 1 by 2n plus 1. Here minus 1 power 2n plus 1 value is minus 1. Therefore, x 2n plus 1 equals 2n plus 1 minus 1 by 2n plus 1. Here in the numerator plus 1 minus 1 get cancelled. Then we will get x 2n plus 1 equals 2n by 2n plus 1. Here we are taking the limit as n tends to infinity on both sides. Then here in the denominator we can take a 2n as a common. Then we will get 2n of 1 plus 1 by 2n. In the numerator and denominator 2n will get cancelled. Then we will get 1 by 1 plus 1 by n. When we are applying the limit as n tends to infinity, we will get 1 by 1 plus 1 by infinity. Here 1 by infinity value is 0. Then we will get 1 by 1, that should be equal to 1. Therefore, limit of x to n plus 1 as n tends to infinity value is 1. The limit is unique in both the cases. Hence, given sequence is convergent. Thank you.